Nice having you again, my wonderful scholars. Jam past question 2001, question number 24. A resistance R is connected across the terminal of an electric cell of internal resistance 2 ohms, and the voltage was reduced to 3/5 of its nominal value. The voltage was reduced to 3/5 of its nominal value. The value of R, X, that's the capital R, X. Okay, in order to simplify the equation, we have to bring out the parameters. Solution. A resistance R is connected across the terminal of an electric cell. We have resistance R, not given yet. Okay, let's say question mark. And the cell has internal resistance. In every cell or battery, there is a resistor inside the cell. It's called internal resistor. Then the resistance of that resistor is called internal resistance. Those electrodes inside the cells are the resistors. And that property of and the property in the resistor is called resistance. The ability of a conductor to resist or to go against the flow of electric currents. Okay, then the internal resistance becomes 2 ohms. Okay, the total energy in a cell when the cell is doing no work is EMF. Then notice, because of the presence of internal resistor that has internal resistance, the voltage that will come out from the cell is 3/5 of its nominal value. That's the EMF. So what will come out from the cell is not 5/5. It's not complete EMF. It's a fraction of the EMF that comes out. And that fraction of the EMF that will enter the circuits, that will leave the cell to enter the circuit, is 3/5 of its nominal value. This is the EMF. Therefore, voltage is 3/5 EMF. That's the nominal value. This is the voltage that enters the circuit, the driving force that will enter our circuit. So that means we also, let's call this external potential difference. External potential difference, the one that comes outside from the cell to enter the circuit. Then if 3/5 enter the circuit, that means 2/5 wasted inside the cell. Then internal voltage, 2/5 of EMF. You can notice the fraction. 3 out of 5 entered the circuit, 2 out of 5 remained in the cell or wasted in the cell. External voltage, internal voltage. Join both of them together, you get your EMF. So this is the division or the fraction of energy distribution. This one enters our circuit, this one burns in the cell, making the cell hot. We'll continue. The value of R, X. Okay, from the parameters, you will know that the best way to find this is to go back to the formula for finding EMF. Because here we have internal resistance, we have external resistance, and we have voltage supplied and voltage wasted inside the cell. Then recall, E is equal to I, open bracket, capital R plus what? Small r. This formula for finding EMF. This formula was gotten from EMF is equal to external voltage plus internal voltage. EMF equal to external voltage plus internal voltage. The voltage is joined together will give us our EMF. Then let me still put more emphasis on this formula. Then the external voltage, let's continue your EMF. The external voltage will be I capital R. The capital R is the external resistor, the resistor in the circuit, plus then the internal voltage. The current is the same, we maintain the current, then small r. Small r, that's the internal resistance. So this voltage inside, the voltage that was wasted inside the cell, the voltage supplied to the circuit. Join both of them together, you get your EMF, the total energy housed in the cell, EMF. Then since current is the same in series connection, then E is equal to factorize. I comes out, we'll be having R plus small r. That's the formula we will deploy to solve this question. So let's forge ahead. Okay, let's see what and what we have. The EMF wasn't given. The EMF wasn't given, we'll maintain it. It's equal to, our current is not stated, we don't have current yet, I, open brackets. Our capital R is what we're looking for, plus internal resistance was given 2. Okay, so we have series of unknown. We have series of unknown, then we'll continue solving. Let's find a way to get current. Let's start with current. Okay, notice. To get current, we say from Ohm's law, I is equal to V over R. V over R. Then let's see if there's any means to get this. Let's take if voltage was given. Okay, this is external voltage. External voltage, we have external voltage, but the external resistance wasn't given. We don't have external resistance. So even if we put this, external voltage is 3 over 5 EMF over, then external resistance wasn't given. So we have 2 unknown, it can go. Then let's try another means. This internal voltage is 2 over 5 EMF over internal resistance is 2. Therefore, this can go. This formula can go. We have the internal voltage, we have the internal resistance. Here we have the external voltage. We do not have the external resistance. So we can use this to get our current. So recall, current in the internal voltage is the same as the current in the external voltage because it's series connection. The circuit is in series connection with the cell. The current coming out from the cell enters the circuit, so it's the same. So we use this to get our current. Then before we can bounce back here, let's find current. Okay. Okay, to get current is equal to 2 over 5 E, that's EMF, divided by 2, where this is the internal resistance, internal voltage. Then we'll be having 2 times E is 2E over 5. This is like over 1. Times, we're changing division to multiplication, then it becomes 1 over 2. 2 cancels 2. Therefore, the current in the cell and in the circuit, the current both in the cell and the circuit becomes E over 5 amps. This is our current. Our current is EMF over 5 ampere. Then we'll bounce back. Recall, the consideration is finding R. That's our concern. So to find R, EMF is equal to, so we substitute I as E over 5. We'll continue. R plus 2. Then notice something. 5 can go up, E can come down. Mathematically, it's allowed. Cross and multiply. 5 goes up, E goes down. So I'm having 5 over 1 is equal to E over E, R plus 2. So that E can cancel what? E. That's rule of mathematics. Then we continue. I now have 5 is equal to R plus 2. Then our concern is to get R, to find R. Then make R the subject, 5, 2 be going that side, minus 2. Then external resistance becomes 5 minus 2, 3 ohms. Then let's go back and check if the external resistance is greater than the internal resistance. That's what it should be. So our external resistance is 3 and internal resistance is 2. That is why, notice, Ohm's law says where there is a greater resistance, there will be a greater voltage. Ohm's law, V is equal to IR. The more the resistance, the more the voltage, provided current is what? Constant. Provided current is constant, according to Ohm's law, the higher the resistance, the higher the voltage. We have higher resistance in the circuit, lower resistance in the cell. Therefore, we'll be expecting higher voltage. Recall, the voltage in the external, the voltage of the circuit, which is the external resistor, is 3 over 5. 3 over 5. voltage in the circuit or the external voltage is 3/5 of EMF, while the internal voltage is 2/5 of EMF. Because we have a greater voltage here compared to here, we'll be having a greater resistance. That's why we're getting 3 ohms. And here we're having 2 ohms. So observing from our option, the best option there is option A, 3 ohms resistance. Thank you. Stay tuned as we push ahead.